Now for section 11.5, we want to go about finding minimum spanning trees in weighted graphs. So the previous algorithms were all about finding a spanning graph. Now, if our edges are weighted, we want to make sure that we can find the most inexpensive spanning tree. There are two different algorithms here, Prim's algorithm and Kruskal's algorithm. Both will result in a minimum weight tree, and all I want to do is just work through the algorithm with you once in each case. So, Prim's algorithm, they're both what we call greedy algorithms. That means you add the cheapest thing you possibly can add at each step. In the case of Prim's algorithm, you want to add the edge of least weight to the spanning tree that is connected to vertices already processed in the algorithm, as long as they don't form a cycle. What's beautiful about both these algorithms, Prim's and Kruskal's algorithm, is that you know if you are creating a spanning tree on a graph with n vertices, you only have to add n-1 edges. So you know exactly how many steps you need to take before your algorithm terminates. In the case of Prim's algorithm, as I said, you just greedily add minimum weight edges connected to what you've already built before. So let us go ahead and do that. So it's got to be incident to a vertex already in the tree, but not forming a cycle. And it maintains the connectivity of your created subgraph. I guess we need to label our vertices to make sure we can follow what's going on here. This graph has 18 vertices, so it's going to take us 17 steps. So you'll notice the weights of the edges range from 1 to 8. That means that we have a freedom of choice here to begin our construction with any edge of weight 1. And I'm going to start by adding the edge OQ. And let me just write the edges down in the order that I am adding them. So the next step is to examine all the edges incident to the edge we just added, OQ, and look at their weights. So we have a weight 4, a weight 2, a weight 4, and a weight 3. Of those, the least expensive is 2, so the next step will be to add the edge OP. And when I do this, I'm going to note what the cost of each edge is along the way. Okay, now we have to consider all the edges incident to the yellow edges, so the vertices O, P, and Q. We have, we have a weight 2, a weight 1. Well, obviously a weight 1 is something we can add, so let's go ahead and just add that. We can't get any better than 1, so let's add PE of weight 1. Now you have to consider everything adjacent to Q, O, P, and E. That's 5, weight 4, weight 2, weight 3, weight 5, weight 4, weight 3. Nothing's creating a cycle yet, so we will go ahead and add that weight 2 edge. So let's add PD of weight 2. And now what do you find is the next cheapest edge? Looks to me like it's weight 3, and you have a choice either to add CD or to add RQ. I picked RQ, of weight 3. Now that we're using R in our tree, we can add the edge Rn of weight 1. So we can add this edge here. Oops, that edge right there. And from there, since n is now in the subgraph, we can add another edge of weight 1, Nm, and we can add MC, also of weight 1. Now becomes a little bit more interesting. I think we've used all the edges of weight 1. Are there any edges of weight 2 that we might be able to add? Oh, here's an edge of weight 2 that's connected, and here's an edge of weight 2 that's connected. I can add either one, and in fact I will probably add both of them in 6. Well, I have to add one of them and then think. So let's add, oh, look what I've done. I'm sorry. Okay, so what I've done is I'm going to add RS as the edge of weight 2, and where you see those dotted lines, those are edges that are forming cycles, so we won't ever have to consider them again. And we've added RL of weight 2. Looking at vertex S, notice that we took away the edge LM because it forms a cycle, and then from vertex R, I'm going to add RK, also of weight 2. Now let's see, what can we do? There's an edge of weight 3, which I believe is the next cheapest, going from P to G. Ooh, I put everything down. Did you really want me to put everything down? Well, let's just say you followed everything I did. You could stop it and do this on your own and see what I chose. But I chose PG of weight 3, followed by GF of weight 2, followed by GI of weight 3, BC of weight 3, and then after that, all the weight 3s have either been processed or create an edge, and we can look at the weight 4s. Lots of those create cycles, but there are a couple we can add, AB and QJ. And then the very last step will be to add the weight 7 edge, HG. So the yellow edges here represent our minimum weight spanning tree, and if you add up all the weights that we kept track of as we went along, you will see that the weight of this tree is 42. One more video, and that will be Kruskal's algorithm, and it will be even greedier in its construction, but it won't do any better.